Hello, today we're going to be talking about 3.3, multiplying binomials. Let's remind ourselves what a binomial is again. A binomial is just a polynomial with two terms. For example, 2x plus 4. This is a polynomial with two terms. Okay, so before we talk about multiplying binomials, let's talk about multiplying monomials. So here we have 2x squared times 3x to the power of 4. Now you see it's written in parentheses and they're written close to each other, which means we want to multiply. Usually when we write multiplying for numbers, we write 4 times 5. In this case, we write it in parentheses because the multiplication sign can be mistaken for an x. So this way it's more clean and easier to see. Okay, so I'm going to tell you that 2x squared times 3x to the power of 4 is actually 6x to the power of 6. Now, how did we get there? Well, let's break it down. 2x squared is actually 2 times x times x. How do we know that? Because x to the power of 2 is x times x. Just like how 4 squared is 4 times 4. It is not 4 times 2. Okay? So be careful. So we have 2 times x, and we also have 3 times x times x times x times x, because we have x to the power of 4, so we're multiplying x by itself 4 times. 2, 3, 4. Okay? So now, what is 2 times 3? We know that's 6. And now we have x times x times x times x times x times x. That is 6 x's. So really what I did is I multiplied the coefficients to get 6, and I took the exponents and added them. 2 plus 4 is 6, and that is how I got my answer without having to write out everything. Okay? So let's move on to the next example. Here we're going to talk about the distributive property. Now it's called the distributive property because we're taking A and it's being multiplied by this entire expression. So we want to distribute A into each expression. So what is A times B? Well, that's A, B, and then we have to add A times C, which is just A, C. So that's the distributive property, where we take the A, or whatever's on the outside, and distribute it to the entire thing in the parentheses, the entire expression in the parentheses. So let's see that applied to numbers. So here we have 2 times x plus 4. Again, we want to distribute it to every single expression in the parentheses. So what do we get? 2 times x is just 2x, plus 2 times 4, which is just 8. Okay, now let's talk about FOIL. This is the FOIL method. And now this is when we get into multiplying binomials. So x plus 3 to the power of 2. Let's expand this so we can better work with it. Remember how we talked about x to the power of 2? It's just x times x. So x plus 3 squared is actually just x plus 3 times x plus 3. So here we have one binomial and another binomial, and we want to multiply them together. So let's use the FOIL method. FOIL stands for first, outer, inner, and last. So the first thing we'll multiply are the first terms. So this is the first term, this is the first term. Now we do the outer terms, let's do the first terms. So x times x times x, we know that's x squared, okay? So let me write this in blue actually. X squared. Okay, so we did first. Now let's do outer. Outer, so this is on the outside and this is on the outside. So what is x times 3? That is just 3x. Done with outer. Now let's do inner. Sorry. Inner. So this is on the inside and this is on the inside. So 3 times x. That just gives us 3x plus 3x. Okay, so we did inner. And finally, let's do the last. Let me choose a different color. This is last, and this is last. This is the last term, and that's the last term. So what is 3 times 3? It's 9. So we multiplied the first terms, the outer terms, the inner terms, and the last terms. Now we need to simplify. We can't just leave our answer like this. We have to get in the habit of simplifying our answers. And again, this just goes back to adding and subtracting polynomials. X squared. There's no like terms, so we'll leave it alone. 3x and 3x, these are like terms, so let's combine them. 3x plus 3x is just 6x. And 9 is our constant. We don't see any other constant, so we can't combine it with anything else. So this is our final answer. So now we've multiplied 2 binomials. Now let's apply this to a real-world example problem. Okay, Arlo's doghouse is a square, so that means let's just start drawing out the problem as we read it, right? Otherwise we'll get overwhelmed. So his doghouse is a square, so that means the length is the same size as the width, okay? He will get a new doghouse, which is 5 feet longer in length and 3 feet shorter in width. So for now, let's say this is width and this is length. So if his new doghouse is longer in length, again it's by 5, L, and it's 3 feet shorter in width. So we'll make it shorter. Okay, so let's pretend his doghouse would look something like this. Now we want to write an expression to represent the area of the new doghouse. Okay, so here's his old doghouse, right? I'm saying that this is length and this is width. They are the same size. So we can both represent both of them by x. Because whatever x is, let's pretend x is 5, right? If x is 5, then the width is 5. And if x is 5, then the length is 5, which makes sense because it's a square, so the width and the length will be the same. So instead of using L and W, let's use x to represent the length and the width. So this is our new doghouse, and this is our length, this horizontal line. And we know it's 5 feet longer than the original length. So what's the original length? It's x. So our original length is x. But now our new length is 5 feet longer, so we have to add 5. Okay, so our new length will be represented by x plus 5. And now what is our new width? Well, our old width was x, and our new width is 3 feet shorter, which means we have to subtract 3. So our new width will be represented by x minus 3. And now we are asked to write an expression to represent the area of the new doghouse. Remember, area is just length times width. And our length is x plus 5, so area equals x plus 5, which is our length, and we'll multiply it by our width, x minus 3. And this is what we saw before, where we were multiplying binomials, and we can use the FOIL method. First, so let's multiply the first terms, x and x, gives us x squared. And now let's do the outer terms, x and negative 3. That negative is important. So that would actually give us negative 3x. Now let's do the inner terms, positive 5 and x. This gives us plus 5x. And now finally, we'll do our last terms, which is positive 5 and negative 3. So this gives us negative 15. Now we're not done because we need to simplify our polynomial by combining like terms. So we actually get x squared plus 2x, because we combine these two like terms, minus 15. So this polynomial represents the new area of the new doghouse, And now we can follow it up with another question. If Arlo's doghouse was 5 feet by 5 feet, what is the size of Arlo's new doghouse? So remember, Arlo's doghouse was a square where we represented the length by x and the width by x. And we know that it was 5 feet by 5 feet, which means the length and the width were 5 feet, which means x was 5. And remember, the area of the new doghouse can be represented by this polynomial. And how can we find the area of Arlo's new doghouse? Well, we know that the old doghouse had a length and width of 5, so now we can plug it in. So what would that, we plug in 5 for x, so 5 squared plus 2, 5 minus 15. 5 squared is 25, 2 times 5 is 10, minus 15. And that would give us the area of the new doghouse. And that is how we would apply multiplying binomials in a real world